Right, let me run you through how to construct this triangle EAF. Now, this is in a case where you are given the perimeter. In this case, I think the perimeter was 115 millimeters. The vertical angle was 45 degrees and the altitude was 40 millimeter. The first thing you'll do to construct this triangle EAF is to get half of the perimeter. In this case, it's 57.5 millimeters. All right, so let's first of all talk about the plan so that you can understand it very well. We construct this. This is B, this is A. And this should be the vertical angle 45 degrees, and this is C. Now, BA and AC should be equal. So BA and AC should be equal. All right, they should be equal. Now, how do you construct a 45? You first of all construct a 90 degrees. Then you bisect it. That's how you come up with a 45. So, once we are done with that, we have to erect a perpendicular at B. You know how we make a perpendicular line. You also construct a perpendicular at C. These should meet in D. Now, how do you test this to say it's correct? DB should be equal to DC. Are we together? BD should be equal to DC. Once these are equal, then you can make a circle here, which is this circle. Once you have made this circle, what do? You go to A with your compass at A and pick the radius of 40, which is our altitude. Then you make an arc right here. You make an arc. Okay. Then you join what is called a common tangent. A common tangent is a tangent that touches two circles just at the tangent. So you're going to find that this will be your triangle. C, let's say it meets here at E. So CEA. Now, there are two types of tangents. Okay. The first tangent is when you draw some triangles will come out like this. Meaning you have got two tangents. Let me write here. You have got two tangents that will touch the circle from outside. In such a case, the two circles, the tangents touch it from outside. The other two tangents is for the circles that are intersecting. For example, I've got circles that are intersecting. The tangent can be outside or just right here in between. You have got a tangent. All right. So for this triangle, the tangent is inside. But for some other examples that you are going to pick, or the exercise that you might be given on the exam, the tangent might be outside. So let me just run you through how this is done. At least we have understood the plan. So we are saying BA should be half the perimeter, 57.5. So this is how it was constructed. See, 0, 1, 2, 3, 4, 5.5.7. That is our BA. So once you make your BA there. Now we want to make AC. The first thing we do is pick any radius. Remember? Pick any radius. In this case, we picked this one. We make an arc there. We stand from here. We make an arc right there. And we stand from here and make another arc there. Standing from here, we make an arc there. Then this is our 90 degrees. Now we want to make 45. So we bisect this angle. How do we bisect this angle? You pick this radius here. You pick this radius here. Pick this radius. Are you seeing it? You pick that radius. And standing from both ends, first here, you make that arc. Are you seeing it? Make sure that your radius are correct. And you also stand from here. Where the two arcs intersect, that's where your CA is. Now CA should be equal to BA. CA should be equal to BA. So this same length, you transfer it to this length using your rule 57.5, or you can use your compass just by here by putting it like this. Then you make an arc there. That gives you. Then from B we raise a perpendicular. You know how we raise a perpendicular? Just like we did to this one. You get any radius. You can get any radius. You make an arc here. You stand here, make another arc. Stand here, make another arc. Are you seeing it? Stand here, make an arc. Then where the two arcs meet, you draw the line. You do the same at C. You are going to find that these two perpendicular lines, they are going to meet at D. Now, how you prove that this thing is correct? DB should be equal to DC, so that you can construct this circle. So if you measure DC, it should be equal to DB. Are you seeing it? So that you can come up with this circle that touches both point B and point C. Once you have done that one, the next thing is to stand from A and pick the radius of 40. Using your rule, you pick the radius of 40 right there, and you stand at A and make this radius here. What we are going to find out is that this circle